makes some sense to me. Profit depends on advertising. The output depends on the input. Okay. Next thing is to put this into your calculator, list 1 and list 2. I'm going to go ahead and do that, and then I will do the same, and we'll calculate the regression equation. So let me know if you need some guidance on that. It's under that stat, edit, things like that.
And then I hit second quit, and then I go where?
Stat, calc, and then it's like 8. Yeah. So this time we're rounding to 4 decimal places. So I see that it's 204.560. Yeah, 8 plus 0.8473 x. So give that a try. Make sure it is what we expect.
$205.4081.
204. I heard 205. 204.56008.
Well, when I added them, I got.
Oh no. You're not. The second one's got a variable with it.
Oh, okay.
So it's a slope and a b value. It's
Okay, that's correct.
Okay, fantastic. Now, the next one here is to predict the profit in dollars for a week when $195 is spent on advertising. So that's your X value. We're putting that value in for X. Okay, so we're your calculator, you have to just re-enter this equation with that value. Some software will actually calculate an estimate for you, but kind of stuck with the calculator there.
Okay, it would be 369.7843.
369.78, like that. Okay, go ahead and give that a try. Make sure that that works. Should be good.
Yep.
All right. So now we're up to the hypothesis testing stuff. This is where, again, well, not this one. This one's fine. This is the beta 1 equals 0. Beta 1 does not equal 0.
Mm-hmm.
It's always this. It's always this. You can put that on a note sheet. It's always that for your null and alternative hypothesis. Did that take it?
Yeah, I'm still typing it in.
Okay.
Correct.
All right. So let's try this for the next one here because I want to see if I can help you figure this out in case you got to do it on the test. We did use formulas yesterday. I don't think that's really the way you want to go. Yeah, never mind. Let's you can get back to me on that. I mean, the way to do it with formulas is going to be on that reference sheet, but I'll just give you the t and the p value. My concern is you don't know how to do it for the test, and I don't know if it's going to be on there. So I guess we'll find out when we get to the test practice. So the t is 5.995, and then the p value is 0.0093.
Got that.
You got it?
Yep.
All right. So the next stuff is the whole hypothesis test. So you have to compare your p-value, which is 0.0093, to the alpha level. The alpha level is given as 0.05. Is this number less than 0.5 or greater than 0.5?
Less than.
Less than. And that means you reject. And we can conclude that the relationship is significant. The coefficient of determination, that's r squared. That is in your list there when you did the regression. So if you don't have it, you have to go back and do a second, or not second. It's a stat calc, regression. I think it was 8, and get that value. Unfortunately, like it's not like what we're used to, which is scrolling. You have to actually just read. Like if it's gone from the screen, it's gone forever. So this case, I've got
0.96.
Yes.
1.
4 decimal places, 07. 07. All right.
Hope it didn't like that.
Really?
Yeah.
.9607. Didn't like that. I mean, that's what I'm seeing in my software.
Yeah, that's what I got too.
Yeah, not sure. I mean, I couldn't tell you why this is wrong. So you can try changing the last decimal place. You can look
The
at
0 wouldn't be a 1.
No, it 4 means you're going out 1, 2, 3, 4.
Yeah.
So the one after the 7 is a 0. So it rounds down. Yeah, I don't know. It's a small thing. So
Sure.
what you could do is go and practice another version and check the answer and see what's different about it compared to yours. I don't really recommend doing that. I mean, it's a lot of effort to do that. So I think for 1 point, probably best to move on.
Yeah, that's fine.
Okay, so let's look at number 18 here. We're almost done.
I'm trying to see what the answer is. I'm just curious.
Yeah, you might change the last decimal place by 1. There is an adjusted r squared value, but it's never used. So it would be odd that they wouldn't just take the value that you were given there.
It was 9230.
Okay, so 9230 is the adjusted r squared value.
Okay.
0.92, yeah, and no, that is okay. Sorry, that is now I see. I was giving you the R value 9230. That's why I wasn't taking it. So you got to, it's there, R and R squared are different.
Okay.
I was looking at the wrong row as well. Okay, for the next one here, we need some formulas for calculating T. T is B1. Let me go grab it for you. All right, so there's the formula for T. It says calculate the test statistics. It's B1. B1 is the slope. The slope right there, that's B1 over SB1 0.2777. So you just calculate that if you know the formula, right? It's like, you know the formula, you got it. If you don't,
6.48.
yes.
Sweet. Okay, I got that one.
All right. 19. Okay, so 19 is different. You have to find the critical value this time. Let me go ahead and snip that in. All right, so the this time it says find the critical value. So it has nothing to do with what we just did. The critical value is based on the T distribution and the degrees of freedom. So the degrees of freedom is n-1. So in this case, it's 15. So there's a couple ways to do it. One is you can go to a table, like they're saying here, or you can do your calculator, which I don't think we've done in a while, but I can talk you through it after I figure out where it is. All right, so second, you want to go to second distribution, which is above the vars. And then it's the T CDF. No, you want inverse, don't you? That here. All right, that's not going to work. You're going to have to use the table for this one. Sorry. That does not have the value. Okay, let me pull up the table. And then this is degrees of freedom, 15. Okay. All right, so here's what I'm referring to. If you go to the reference sheet, the way this works is you go to your degrees of freedom, which is n-1, so 14. And you have to figure out how much area is in the tail, which is this alpha level. The alpha level is the right tail probability. So in your problem, it's 0.05. So you're looking for the intersection of these, which is there at 1.763. So that is your, well, I don't know why it's not lining up perfectly. Oh, it is. It's just going out one more decimal place. Okay.
Didn't like that answer.
All right, let's take another look here. Oh, degrees of freedom are, sorry. N is 16. So degrees of freedom is 15. So I'm looking on the wrong spot. Right there. All of that down there. 1.753, which is not there. What is going on here? What is going on? We're doing 19 here.
Yeah.
Critical value. Oh, so it's a two-tailed test. That's the issue. So I remember we wrote beta 1 equals 0 for the null hypothesis, and the alternative was beta 1 not equal to 0. That's a two-tailed test. So you have to split this in half, 0.025. So that means we're not looking there. We're now looking there under the 0.025 column. So 2.131, which again is not there. What is going on here? Wow. All right, I'm going to do it differently because I'm getting a little frustrated here with this. Maybe it's n-2. All right, let me do a quick check on this.
Okay.
Degrees of freedom, regression. Minus number of predictor variables, n minus k minus 1. So is it 2? Let's see here. 5 degrees of freedom is 4. So it's n minus 1 and n minus 1. Okay, let's do it another way. Let's do a calculator. Calculator, t distribution. All right, so we want in the right tail, we want 0.025. Does it say right tail? No, two tail. Degrees of freedom, 15. 2.131. Wow. It's like right in the middle. Those two values. Can you check another version, or is that out of the question?
Yeah, I can. Should I check?
Yeah, can you? And I just want to know the n value and then that's not gonna change. Just the n value and the answer, if you can tell me.
Okay. Oh shoot, I got it wrong. It was 2.145.
Okay. All right. So we will move on here. I would actually ask the teacher about that if you care to get the point back, because it's not in, unless you think it's n-2, which is not what I'm seeing as your degrees of freedom. Let me go back and look at your reference sheet. Maybe you guys are using n-2 for your degrees of freedom and regression. I remember your teacher not putting degrees of freedom on the regression sheet for whatever reason, or the reference sheet. Okay. Yeah, not sure. Okay. So I think the takeaway here is it's actually n-2, and that's what establishes that as the answer. Okay. The next question here is upcoming. One more multiple choice here. The dependent variable. So the dependent variable depends on the independent variable. If the independent variable is measured in pounds, the dependent variable must be some unit of weight, can also be measured in pounds, cannot be in pounds. Okay. So it's like input and output. It's one of the last two here. The reason I'm not sure is that I don't know why you would want it to be in pounds. Like if you think of like your weight measuring I don't know how fast you can do something.
It can be measured in any unit.
Yeah. Okay.
Yeah.
So, all right. So we're going to move to the review. Is that right?
Yeah.
Okay. Let me quickly navigate there so you can say, here's how to find it fast, so I don't waste time doing that. Where do I go from there to?
You can go to dashboard.
Okay.
And then if you scroll down for tomorrow, exam 3 simulation.
Okay. 40 questions. All right. All right. Do you want us to go through all of them, just the numerical ones? What would be best for you?
Probably the numerical ones for now.
Okay. All right, let me grab question 2. All right, so let me go back to the other screen. Make sure you're seeing that. There you go. Okay. If the coefficient of correlation is 0.8, that's R. That is R. Okay. The coefficient of determination is R squared. So if R equals 0.8, R squared is the square of 0.8.
Okay.
So it's 0.64. Okay. Now this problem is so that's the answer there. This problem is related to the one where if it was flipped, if they were giving you the coefficient of determination, then the correlation coefficient would be plus or minus. And the reason is if they give you R squared, let's say they tell you R squared is 0.64, when you take the square root of R squared, it's plus or minus 0.64, which becomes plus or minus 0.8 basically. So it depends on the direction you're going for that answer.
Okay.
All right, let's keep going here. Question 3. All right, in a regression analysis, SSE equals 600 and SSR equals 300, then the coefficient of determination is. You again, probably best to have this this reference sheet I've been telling you about out there, but here's the main formula you need. It's that R squared, which is what the coefficient of determination is. R squared is SSR over SST. So you have the 300, but you don't have SST. SST is the sum of squares total. The sum of squares total is the sum of the sum of squares regression plus the sum of squares error. So they're giving you 300 plus 600. SST is 900. We talked about how you'd probably have something like this on there. So you definitely got to know this formula to be able to answer it. Any questions on that before we move on?
I think so.
All right. All right, so your test covers more than regression, even though it seems like that's all we've been doing lately. It says the hourly wage of a computer programmer with 2 years of experience has been $21.80. Wow, that is a low wage for a computer programmer. Because of high demand for computer programs, it is believed that there's been a significant increase, very important, that word right there, increase in the average number of hourly wage of computer programmers. To test whether or not there's been an increase, notice they're saying it yet again because they're trying to really emphasize it for you. Which of the correct hypotheses to be tested? So the thing that they are trying to prove is the alternative hypothesis. So increase corresponds to greater than. So which of these alternative hypotheses has a greater than in it?
The second and the third one.
You're looking at the right column only.
Oh, the third one.
Yes, this is the alternative. You actually don't care about the null at the moment. So this is the right one that matches with it. We talked about the idea that if the let me do it this way. If the alternative is, for example, a greater than, the null is a less than or equal to. If the alternative is a less than, the null is a greater than or equal to.
Okay.
If the alternative is a different, usually this is the word different, this is an equal to. So this table will help you to remember all the possibilities that you might see.
Okay.
All right, number 6.
So it would be the third one then?
Yes.
Okay.
In a data set, if a data set produces SST equals 1,000 and SSE equals 600, then the coefficient of determination is. So again, you need those formulas we had from the earlier problem here. You need to know that the sum of squares, or the regression coefficient of determination R squared is sum of squares regression over sum of squares total. So this time you have the bottom is 1,000, okay? And then the other one here, grab this formula, allows you to find the other value that you're missing. So we know that 1,000 SST equals SSR plus 600. SSR ends up equaling 400. So you divide those and you get 0.4.
The test is a lot easier than the homework, huh?
Sure is. Sure is. And to be, why is that? I don't know. That's good for you though. It's good that it's not like the homework, easy to be off by a digit or two.
Yeah.
So 7 here, this is 7. I couldn't quite get all of it to snip the screen. There's some words up here at the top you can read if you'd like, but it says the p-value for the difference between the two populations means is. Okay, you have to remember, well, what kind of test is this? So this is a two sample. That's where you got to start. Are they giving you one sample or two sample? And then you have to decide whether it's a Z or a T test. Because of sigma, it is a Z test. So now we just remember how to get to it. So that's stat test, and then stat test two sample Z test number 3. Now, when you open that up on your calculator, you'll see that there's the choice between data and stats. When they're giving you the outputs, that's the stats. So this for this problem, you want stats. So notice it asks you for sigma 1, sigma 2, x bar 1, n1, x bar 2, n2.
All right.
So sigma 1 is not 112.5. It's the square root of 112.5.
I don't see an x bar 2 on mine.
Did you click on stats?
Yeah. I went stat test. And then is it two sample?
Yes, it's number 3, two sample Z test.
Okay, now I clicked something wrong.
Yeah. If your input doesn't match what you have, you got to go back and restart to find it.
Oh.
All right. So now sigma 1 is the square root of 112.5. The reason it's square root is because it's sigma squared. If you see a squared, you have to know to take a square root. Sigma 2 is the square root of 54. X bar 1 is 82. N1 is 45. X bar 2 is 88. And then 36. And then I think you have to decide whether it's one tail or two tail down here. Yes. Okay. Let me go back and read the question, see if it. Okay, so we actually do need that initial part to determine what type of test to do, whether it's one-tailed or two-tailed. Come on. All right, so it says a statistics teacher want to see if there's any difference. That word difference is what tells you the test. So difference is, go back up and look at one of our previous problems here. Difference is always a not equal to. Okay, so go ahead and calculate that for us, please.
.0027.
And it's there. That's a good sign.
Well, it's .00269, but figured. Here, that's
So does that round to
yeah.
0.0027? Yes. So you're in good shape. All right. The error. Okay, that's a non-numerical. All right. Let's look at 9 because it's kind of like it's really important to know the direction of the null and alternative hypothesis. So when you're reading this, you're looking for languages like bigger, smaller, increase, decrease, changes, difference. Okay. So let's take a look here. A juice drink filling machine, when in perfect adjustment, fills the bottle with 12 ounces of drink on an average. Any overfilling or underfilling results in the shutdown and readjustment of the machine. To determine whether or not the machine is properly adjusted, the correct set of hypotheses is. So here's what they're talking about. They're saying it's only a problem if it's overfilled or underfilled. So overfilled means less, overfilled means more, underfilled means less. Since they're both there, the interpretation here is that this means different.
Okay.
So you're looking for the alternative hypothesis. You're looking in this column right here, that's different. Which one would that be?
Not equal to.
Yes. You will get a problem like that. It's not difficult if you know what words to look for and how to interpret them. Okay, for a one-tailed, upper-tailed hypothesis test with a sample size of 26 and a 0.01 level of significance, the critical value of the test statistic t is. So here's what they're saying. They're saying here's your t distribution, and they want 0.01 in the tail. Okay, and we're looking for the t value here. The degrees of freedom is always n minus 1, except for regression, then it's n minus 2. So in your problem here, it's 26 minus 1 or 25. So in the what do I call it? I keep calling it like the formula sheet. If you go down to your formula sheet and look on page 6, which I'm going to snip in here, I'll show you how to find it. You have to first look for the degrees of freedom on the left. So the degrees of freedom we have is 25. That means we're looking at the row with 25 in it. Now, they're telling you up here that it's a right tail probability. They're telling you that. They're saying it is right tailed. You don't have to make any adjustments for that. That was the issue we had in the previous problem is because it was two tailed, we had to make a small adjustment. This one is right tailed. This one says upper tail. That means right tail. Everything's kind of lining up. So we're looking for 0.01 in this table. There's 0.01, and then find the intersection, 2.4851, right there. Okay. There's no other way to do this. I mean, you can use software, but your calculator doesn't have that capability on it. It doesn't do like what's called an inverse calculation to give you this, unfortunately. I could show you how to use the calculator to use each of these values to find it, to find the area and see which one is closest to 0.01, or you can use the table.
I'll have the table on the back of the test. So
okay. All right, very good. All right, so number 11. So you can see some of the problems are really straightforward. They're just like this one up coming here. It's like, you wish they're all like this, but all right, the coefficient of correlation, that's R. R equals 0.4. The sign of R is the same sign as the slope. Okay, but this is for R. This is for R, not R squared. So since R is positive, slope is also positive. and we can actually calculate it. Actually, we cannot calculate. Sorry, we don't have enough information here. If we had more information, we could calculate. So must be positive is the answer.
Okay.
All right, so here, the next problem is very similar to one you had in the homework assignment, but they're the I don't know, the lesser ones. They're not the big calculations.
Okay.
All right, so they're giving you a bunch of stuff here on the left, and then the T formula was B1 over SB1. This is in your equation sheet, the right side on page 2, sort of towards the bottom. B1 is 1.8. B1 is the slope of the equation. SB1 is 0.2683.
$6.71.
Yes, good. Okay, so we saw that a bunch of times on the homework. Probably get something like that.
Yeah.
I think they like these calculations where they give you a lot of extra numbers and maybe say, you know, have at it.
Uh-huh.
You know, and you got to just know, oh yeah, just got to go look for the formula here. All right, so whereas that one was pretty basic, this one is going to require, you know, more work. We talked about you got to know where to go in the calculator to find your answer. So so let's see here. Management of department stores interested in estimating the difference between the mean credit purchases of customers using the store's credit card versus those customers using a national major credit card. You're given the following information: store's card, major credit card. We want a 95% confidence interval margin of error. Okay, so your calculator will do the confidence interval for you. This is a 2 sample. Again, it's 2 sample because there's the store card and the major credit card. Are they giving you the population standard deviation?
Yes.
Yes, so that's a Z interval. So notice I pause after I say 2 sample because I got to figure out whether it's a Z or a T.
Mm-hmm.
So this is under stat, test, and there's going to be like a 2 samp T interval, Z interval. Let's see here, stat, test, 2 samp, no, 2 samp Z interval. Looks like it's number 9.
Hmm.
You see that?
Yep.
Okay, and then I think you got to choose data or stats again. So you want stats because you don't have the data. And then I see sigma 1.
Yes.
So sigma 1 this time is 10. It is 10 because it's not giving you the variance. It is the standard deviation. Sigma 2 is 8. Then X bar 1 is 140. X bar 2 is, scroll up here.
N1?
N1 is 64. It's the sample size. And then N2 is 49. So go ahead and calculate that. And we want the 2 numbers in the confidence interval.
Okay, 16.68.
Okay, and what's the other number?
23.32.
Okay, so the way this works is that if you imagine these are on a number line here, 16.68, 23.32. This is the confidence interval right here called the CI. The margin of error is half of that.
Okay.
So there's a couple of ways to find it. You can find the width of the confidence interval and then slice it in half, or you can use the fact that the difference in the means is 20. That's 140 minus 120.
Mm-hmm.
to figure out your center value and then just get the distance from there. Is that clear or not?
Yes.
Okay. Because you can't get it directly using your calculator. That's why I'm a little bit of jumping through some hoops here to figure it out. So it is 3.32.
All right. Okay, got that one.
Okay, let me snip in the next one here. All right, so we got the new problem here. They want the standard error of x bar minus x1, x bar 1 minus x bar 2. So it kind of looks like the last one. Standard error is different than the margin of error. They're not the same, very different. The work we just did in the previous problem doesn't help us at all here. Unfortunately, standard of error is a formula. And it's not ideal, but we will be finding it here. Looking for it on your thing there. I guess they don't really give it to you, but they kind of do. All right. So I'm gonna just snip it in now. Just trying to scan one more time and see if they hit it somewhere else. All right. All right. So the standard error, let me highlight it, or actually let me circle it. Standard error is this part in red or this part in red, which they're the same. There's a way to kind of get it indirectly, but you can do it because you need the sigma, you need the S1 squared, that's variance, S1 squared, and then you need S2 squared, N1 and N2. So we've got N1, N2, S1 squared, S2 squared. So it's just a matter of putting it into the formula here. 85 over 10 plus 90 over 12.
$16. Oh wait, I messed that up.
Yeah, try that one more time.
$4.
Okay, very good. All right, let's keep going here.
16.
Yes. Okay. So sometimes if you see like a question like this where we've done like a number of these, you have to say it's going to be on the test. That's the only reasonable thing here. So we're looking for some words that tell us something about the alternative, like less than, greater than, difference. Weatherman stated that the average temperature during July in Chattanooga is 80 degrees or less. A sample of 32 Julys is taken to test whether the weatherman's statement is. To test the weatherman's statement, the correct set of hypothesis is. All right, this one is not worded well. Whenever you see, how do I want to say this? The null, let's take, we haven't talked about the null. The null is always going to have an equality in it. Okay, so here's some answers that we can get rid of right away. That one is out because it's not equal to, that's not an equality. The second one is, third one out because it's not an equality. So it leaves us with A or B. Now, what they're implying here, when it says a weatherman stated the average temperature during July in Chattanooga is 80 degrees or less, what they're implying here is that there's the claim is that it's actually greater than. It's actually greater than 80.
Okay.
And that's where you go back and say, okay, that's the one that's correct here. This one's real tough because they don't use explicit language to say like, we are interested in knowing whether the temperature is hotter. And if it said that, then you would know that it's a greater than. So it's all about, you know, English interpretation of these things here.
Okay.
Let's go to 19. The one-tailed hypothesis test, lower tail, that's important because that means it's the area to the left, is determined to be z equals 2. The p-value for the test is, so here's 2, and we want all the area left of it. So this is where you use your normal CDF, and you need your lower. Your lower is minus 10 to the 99. Your upper is 2. Your mean is 0, and your standard deviation is 1.
Sorry, I'm just getting to the thing. Okay, 0.9772.
Yes. Now, one of the oddities about this question that I think is it's really weird to do a left-tailed test when the z value is all the way to the right. Like this is just an academic exercise. So just be like, because it's easy to think, well, why would they even want that? But when it says lower tailed, that means to go left. That's what you're looking for. If it said right tail, then you go right. And it's just a weird question, but that is you know, the nature of these tests, right? They're not always testing for reasonableness. They're testing for, you know, your interpretation of things. All right. Grocery store has an average sale of $8,000 per day. Definitely not Costco. That's like 8,000 a minute. Store introduced several advertising campaigns in order to increase sales. So their goal is to increase sales. Okay. Determine whether or not the advertising campaigns have been effective in increasing sales. So the other word increase is all over the place. They're telling you that that's the direction of the hypothesis. All right. A sample of 100 days of sales was selected. It was found that the average was 8,200 per day. From the past information is known that the standard deviation of the population, that's important. That's sigma, because its population is 1,500. All right, so here is what we have. Mu, X bar, N, and sigma. Do we have one sample or more than one sample here?
More than one.
So remember, they're just doing the same thing every day. Doing the same thing every day is one sample. If there were 2 different stores, it would be 2 samples.
Oh, okay.
Okay, so this is a one sample. And then you have to decide, is it Z or T? Are they giving you the population standard deviation?
Yes.
So that's Z.
1,500, right?
Yes, so that's a Z test.
Okay.
That's how you have to be able to interpret these. You have to know whether it's one sample or 2, then whether the population standard deviation is given or not. That tells you whether it's a Z or a T test. So that's a stat, test, and then not sure because I got to get there. Can't find my mouse cursor. There it is. All right, that's number 1, right there at the top. All right, number 1, and then you have to decide whether it's data or stats. It's stats because you don't have the data; you just have the values there. So it looks like you need mu 0. Mu 0 is 8,000. Sigma is 1,500. X bar is 8,200, and N is 100. I'd like to make a quick comment about mu and X bar. It's very easy to mix those two up.
Okay.
Because it's increasing, that's the one that you're trying to show is the X bar. Like, because it's increasing, the bigger one should be the X bar. And the reason is you're in your numerator, it's always X bar minus mu. So if you want something to be increasing, the X bar better be bigger than mu. In this case, if it was decreasing, X bar would be less than mu. So having said all that, you have to decide on the direction. It's a greater than. Okay. So go ahead and calculate that. And then you're just looking for the value of the test statistic, which is Z.
Yeah.
What does that
I see
end up being?
1.33.
Boom. Got it. Right.
And the little dot is like infinity, right? Or
the little dot.
After the 3, like it just keeps going.
Oh, okay. So it repeats forever. Yes. So it's not infinity. It just means it goes on.
It repeats. Okay.
Yes. Which in some ways is kind of what we think of infinity, where it's a forever land. All right. Let me grab another question here. So 21, we've done a couple like this. R squared formula, you got to know it. R squared is SSR over SST. But this is not what they're asking for. They're asking for the correlation coefficient. R squared is the coefficient of determination. And it's like, what's the difference? Well, just for now, just memorize that they are different. Don't try to get into the ins and outs of it. They're giving you SSR 2925, and they're giving you SST 4500. To find R, you have to take the square root of this number. But when you take the square root, it's either plus or minus. So that's why you're seeing those answers there. So if you got a calculator handy, go ahead and calculate that.
.806.
Good. All right, let's look at 22 here. All right, a statistics teacher wants to see if there's any difference. What does that mean in terms of the hypothesis test?
I know we did this earlier.
Yes.
I forget.
Difference is a not equal to.
Okay.
Okay. That's really important because the p-value is going to determine the answer here to this. So that's why I've got to do it. Are you given one sample or two samples?
Two.
So this is a 2 sample. Is it a Z or a T test?
Would it be Z?
Is that a Z test? Yes. All right, so we've done a bunch of these. Grab your calculator. I think it's sigma 1. Sigma 1 this time is the square root of 112.5. Sigma 2 is the square root of 54. In fact, these look like almost the same values as one of the problems we did. X bar 1 is 82. X bar 2 is 88. And then N1 is 45. And N2 is 36.
Okay.
The reason we take a square root is because your calculator wants sigma, not the square of it. It wants standard deviation, not the variance. Small difference, but it likely impacts the answers.
Okay. The Z is
We want the p-value. So make sure you choose the
0.
not equal to for this.
Oh shoot, I don't know if I did that. Dang it. Yeah, because I got 0.
Exactly 0?
For P, yeah. Oh yeah, I did choose not equal to.
Okay. Wow. All right. Let me double check. There's not like some decimal places or, 0 point something times 10 to the something.
No, just
Okay.
for P it's just 0.
Standard deviation, square root. All right, I'm only checking because the answer to the p-value dictates everything else. And if we're off on this, it's bad. All right, compute. So I got a p-value of 0.0027.
And that's on a 2-sample Z test?
Yes.
Huh.
You're saying you don't have that?
I did the same. Number 3, right?
It's yeah, number 3. And then I'm there now, so I'm gonna do it as well. So the sigma 1 is the square root.
And then you should get 10.60.
Okay. All right, I'm just entering the data. Next one is X bar 1, 82, N1, 45, 88, N2, 36. Not equal to, okay, calculate. Yeah, I'm seeing, let me snip this in so you can see it. This is what I'm seeing. Do you have these values for Z?
No.
Okay, so let me go back to the test and snip
I
in.
wonder what I did wrong.
Yeah, and this is the key, is like, did you put in all the values in correctly? So
Yeah.
let me snip those in, because it's all about you on the test. You gotta be able to do this. So here's what you mentioned 10.6066, sigma
Yeah, I have
2,
that.
7.34, square root of 54.
Okay, yeah, sorry, I didn't calculate it yet. I have Z as 22.19.
That's way too far apart. Do you have, what's your X bar 1
It's 82.
and N1?
It's 88. Those
N1
match up.
N1 is 45.
N1 is 88. Huh.
N1 is 45. X bar 1 is 82. It's got to match exactly what's here. Then you'll get
Yeah, my X bar 1 and N2 match. And so does, wait, yeah, just X bar 1 and N2 match.
Okay. Well, go ahead and switch to 45 for N1, and X bar 2 is 88.
Okay, I got what you have now.
Okay, fantastic. So the p-value here is less than the 0.05 level. Like, I know maybe like that's it's like, why do we get all this trouble? You got to be able to get this right, but the p-value is less than 0.05. So we know to reject, but notice none of these say to reject in here, which is why your teacher does it that way, because there's a little bit more. So rejecting always means statistically significant.
Okay.
So there is, or there is no. That's the kind of the two differences. The other ones are garbage. Okay. If you reject, this is the reject one. And the other one is fail to reject.
Yeah.
So it would be letter A. All right. So I'm going to call it good here for first lesson here. I'm happy to tack on some extra time tonight as well. I think you got another lesson tonight. Is that right?
Yes.
All right.